Right. Good afternoon once again. I believe all students are able to enter our Google Classroom today. Magandang hapon sa ating lahat.
Afternoon, sir.
Yes.
Good afternoon, sir.
Good afternoon sa atin. I won't be able to open my camera muna this time because I have a lot going on my desktop because I tried recording this one with other applications. Sorry. So hindi ko muna gagamitin yung camera ko. I cannot actually. Anyway, welcome to mid-year. This is a mid-year course. Our course is Abstract Algebra. And I believe you know me already. But for those who do not know me yet, yes, I am Nick Sibaan. And I am a faculty member of the College of Numeracy and Applied Sciences. It's a newly created college. I am under the mathematics department, of course. And I know also that all the three students here are taking Master of Arts in Mathematics. Ayan. So maraming salamat sa pag-enroll. Actually, the minimum requirement for a course to be open is actually 3. Kaya saktong-sakto po tayo, 3 tayo, pangapat na lang ako. Yeah, so welcome to Benguet State University. I hope you will learn something from this course. So for today, before I provide the first batch of lectures, let us have muna some or brief class orientation. Especially that this is a mid-year course, so you expect that the pacing is really fast. More or less 1 month lang po yung duration. That's why we have to provide lectures almost daily. Pero almost lang naman, hindi kailangang lecture lang yung pinapakinggan natin sa bawat araw. So sometimes I'll be giving you activities, yun yung gagawin ninyo for that day. Right? So if you were able to look at the syllabus that I have provided in our classroom, it says there, the very first page, it says there that it has actually no prerequisite course. That's just technical, but since we are talking about algebra, syempre kailangan din natin yung knowledge natin, especially to other courses such as set and logic theory. So a lot of concepts from that course will be applied here or will be related to this course, set and logic theory. I'm not sure if you are taking it or are you done with it. May I ask, sino sa atin ang nakatapos ng set and logic theory? I'm sorry, am I supposed to hear something?
Sir, as for me, I'm currently taking it, sir.
Okay. So, magiging co-requisite na lang siya. Anyway, yes, para hindi tayo ma-shock, no, when we talk about concepts that are really related there. Anyway, as much as or as long as I can, I will give you a brief recap of it or i-discuss muna natin siya bago natin siya gamitin sa course na ito. So, set and logic theory, that's very important. Also, some knowledge from the topics under number theory. This is a master's course naman, no? So we all had our undergraduate. So hopefully that's enough or you can recall your lessons before sa number theory. Lot of notations, lots of concepts from that subject. Even some on discrete mathematics. Marami din doon yung mame-mention natin sa course na ito. So, yes, prerequisite courses, wala, based from our syllabus, doon kasi sa curriculum mismo. But, of course, it would be really helpful if we also go back to other concepts that are normally tackled in other mathematics courses. Assessment in this course, traditional lang. We have our quizzes, our tests, our examination, and I forgot to include here. There will be a chapter devoted for you to present orally in this course. So perhaps that would be in the final term. So I'll be giving you each topic for you, or I mean topic for each of you. You will be presenting it in this class. So aside from the quizzes, the tests, the examinations, problem sets, you will also be doing oral presentation. Anyway, for now, for the entire midterm and some of the final term, I will be the ones providing the lecture. All right, so I think that's for uh, our class orientation, unless you have questions. This is not your first semester, I believe, or is this your first semester?
Hindi po, sir. Pangalawang sem na po.
Okay. How about si Ma'am Sherilyn and si Ma'am Evermy?
An old student na return lang po.
Oh, okay. So anyway, I forgot also, no, perhaps since tatlo lang tayo, apat lang tayo, perhaps we would like also to introduce ourselves para alam natin. So just introduce yourself, tell us your name, and perhaps your work, the place of your work. May we start with yung list natin dito sa ating Google Classroom, starting with Ma'am Kanjao.
Hello po, classmates. I'm Evermy Kanjao, old student po na returning, nagbabalik loob, sabi po nila kanina. And currently, I'm teaching here at Baguio for St. Louis University Senior High School naman po. Yun lang po.
You are a math teacher, ma'am, sa SLU?
Yes po, sir, math teacher.
Okay. Sige po, maraming salamat, Ma'am Kanjao. Since when po kayo nag last na enrollment?
Last sem naman po, sir. Kaya,
Okay. So continuing po, continuing.
yes ko, continuing
Okay.
pala. Thank you.
Okay. Let's also have Sir Rafael.
Okay, good afternoon, classmates. Good afternoon, sir. Sir, I'm from La Union po. I'm currently teaching teachers, sir.
I'm sorry,
And
again,
currently my second,
nawala yata.
sir.
May we request you to
Hello.
repeat what you said. Nawala yata.
Okay, sir. Okay, sir. So good afternoon, classmates. Good afternoon, sir. Sir, I am Rafael Aquino, currently teaching at Kupang Integrated School here in the La Union Schools Division, sir. And currently a junior high school math teacher, sir.
Okay. And also we have Ma'am Sherilyn. Are you speaking? We cannot actually hear you. Si Ma'am, ayun. Meron ba? Mukhang hindi ka namin marinig. Perhaps you would like to use na lang our chat box. Basahin na lang po namin. Yeah. Sa chat box na lang po, Ma'am Sherilyn. Okay, so that's it for brief class orientation. So whatever you did last semester, kung ano yung structure natin doon, yun din po yung gagamitin natin this mid-year term. So you will have two examinations, midterm and final exam. Depende kung ano yung matatapos natin, the topics included for the midterm and the topics included for the final term may vary. So, it's not necessary na mafa-follow natin yung nasa syllabus, depende pa rin 'yon. Okay. So anyway, as you know now na majority of the lecture will be provided to you online, synchronous tayo. And of course, for the activities, normally I provide time for you to do that. Submission will be through our Google Classroom. Yes. So let's now proceed to the lecture. So actually, the first part of my lecture today is an introduction muna of the subject no, before we tackle the concepts that are provided there. So this course again is called Abstract Algebra, but more important or a better term supposed to be daw is algebraic structures. We just named it abstract algebra or sometimes or other authors call it modern algebra. So as an introduction, I have here a brief history of how abstract algebra started as a field in mathematics. So the year is 1800s. And actually, the very first person to use or to uh, it's not abstract algebra that time, no? Pero it's Evariste Galois used the concept of groups. Saan niya ginamit? In solving equations of higher degrees. For example, equations whose degree is greater than 5. So to solve that, gumamit siya ng concept na groups. Also, at the same time, but independently, we have Carl Friedrich Gauss. He ironed out a technique called modular arithmetic, which shared many similarities with groups. So again, groups. At the same time, mathematicians there realized that geometries goes beyond the ones that was devised by the ancient Greeks. Ano yung ancient geometry or the traditional, no? It's the geometries that are stipulated sa the elements. That's by Euclid. So the groups here, the concept of groups were again found to be useful in studying these geometries. So yung geometries na ito yung mga modern geometries, projective geometries, mga ganun. So by this time, the groups become a powerful tool that could be used in many different ways. By generalizing this tool, group theory was born. And from this concept, nagkaroon na tayo ng mga objects na fields, modules, vector space, and of course, that's the start na ng pagka-develop ng abstract algebra. So it came from the concepts of groups. Well, of course, there is a majority of time here where it's devoted to the study of groups. Yes, algebra is a young subject. And because of its nature, no, na abstract nga, may maraming nagsasabi na wala siyang application, but that's actually entirely wrong. If we know how to find it, the applications are actually vast. And accordingly, no, sa authors natin, sa references natin, the application continue to grow each year. So these are some general applications or fields where abstract algebra can be applied. It can be applied to other fields of mathematics like complex analysis, number theory, cryptography, even other branches of science, physics, chemistry, computer science. Now, just a while back, we mentioned that from group theory, after mathematicians generalized that tool, lumabas yung mga objects like rings, groups, and fields. And what are these objects? So, a common person might think of the following, but we will discover later that these objects has nothing to do with the pictures below it. Yan, si Lord, ano yung pangalan niyan sa Lord of the Ring? Si Gollum ba? So we will discover later what we mean by rings, groups, group of individuals, group of people, no. And fields, rice field ba? Hindi rin. So what actually are the concepts, or how do we describe the topics that are included under abstract algebra? In this course, we will identify the unifying properties of various algebraic system. So we highlight properties. We're going to develop mathematical or algebraic structures based on those properties, deduce logical consequences, understand proofs, or understand and construct proofs. Ito yung medyo challenging, no? Normally, kinakatakutan ng mga mathematics majors, proof. In this course, I am telling you now that majority of the time and majority of the activities that will be given to you is on proofs. You're going to prove something. Of course, we apply. We apply the theories that are proven. So, roughly, ito yung gagawin natin under this course. That's just an introduction of the course. We now proceed to the first batch of lecture. Actually, if you also read the syllabus I've given you, this is titled Chapter 0. Chapter 0, some or few preliminary topics. This is not yet the abstract algebra, the concepts or the topics that are really or should be discussed under abstract algebra. This will just prepare us or help us recall the things that we need so that we'll be able to understand clearly the topics included in the latter chapter. So preliminary topics, medyo halo-halo ito. Everything that is needed, as I mentioned, as needed for us to easily deal with the topics under abstract algebra. So the first preliminary topic that I'm going to discuss is on the concept of proof. Because as I mentioned kanina, a lot of time we will be doing proving. So why is it really important for us to appreciate mathematics and proofs? Okay, so when we prove, we always start with definitions. Mathematical definitions. This would allow, how do we or why do we need to define mathematical concepts? Well, we need to start somewhere. We cannot start from nothing. So the very first stage or step is to define the objects, mathematical objects. And also by defining it, na-standardize natin yung definition so that we can communicate with other people, with other mathematicians. So in proving, no, as I mentioned, we start with our definitions. When we have something to prove, a statement to prove, we look at the definition of the concepts that are involved in the statement that we are supposed to prove. So halimbawa, we're going to prove that the sum of two even numbers is even. When you add two even numbers, the result is even. And that's a statement that we're supposed to prove. What definition can be used to prove this statement? Ginamit niya yung salitang even. So by definition, what is an even number? In this course, ang gagamitin natin, yan. A number n is even if it could be expressed as 2 times k for some integer k. Hindi siya natuloy. For some integer k. This is what we mean by this statement. When we want to prove something, of course, we need to recall the definitions of the objects or of the properties that are involved in the statement that we want to prove. If it's odd, so kapag ganito yung form ng even numbers, paano naman sa odd number? Anyone? And by the way, from time to time, I will be asking you questions pala para ano, hindi kayo mabore.
Sir, 2k plus 1 ba?
Yes, it's 2k plus 1. 4k for some integer k. Yes, or for some k element of the set of integers. Okay, let's continue. Meron lang weakness itong definitions natin, mathematical definitions. What is that weakness? It is impossible to define every concept. Of course, you're going to use words to define something, and our language, words, they're finite. So if you're going to define every word that you use in defining the first word, then there will be a time no na magiging cyclic lang siya. Babalik ka doon sa original na word. That's why we need to assign some primitive concepts. So halimbawa ulit, set. What is a set? Are we really going to define it? Because when we define it as ano ba yung definition ng set? A collection of well-defined objects, diba? Distinct, well-defined objects. Anong ibig sabihin ng well-defined? Anong ibig sabihin ng objects? So we need to set. We need to set, or we need to assign, or we need to think of a set as a primitive concept. We are not defining the set, what a set here is. We're just going to provide an assumption about it. So a set is a well-defined, meaning that if S is a set and A is some object, then either A is definitely in S, denoted by A, element of S, or A is definitely not in S, denoted by A, this notation here, not element of A, not element of S. This is our assumption, how we describe a set. Yeah, just follow up to this example kung anong ibig sabihin ng definition natin ng set. Because the concept of set is also a part of our review of the preliminary topics. Well-defined, we are focusing our attention on the meaning of well-defined. When is a set well-defined? It says here that a set is well-defined if you can definitely decide whether an object is a member or is not a member of that set. So we have here our example of a set, and we decide if it's a well-defined set. Let A be the set of some positive integers close to 10. And then we have another set, we named it as N, be the set of all positive integers. So between the two sets, which of them is well-defined, which is not? Or both ba ay well-defined, both are not? What do you think? Anyone? Let me repeat the question. Which of the two sets here, set A and set N, which of them is well-defined? Parehas ba silang well-defined or parehas silang hindi well-defined? Hmm. Set A is the well-defined. Well-defined ba? Let A be, so A is the set of some positive integers close to 10. So I'm going to ask you now, is 8 an element of set A? Number 8, the number 8. Laman ba si 8 kay A? Is it an element of set A? Yes. Yes kasi close sa 10. Okay, let me change the number then. 7. How about 7? Is it an element of set A?
Yes, sir. It's still a part of the set A.
So, kailan siya hindi close to 10? Ang isang number.
Sir, feeling ko yung N ang mas defined kasi ay yung N ang well-defined, set N ang well-defined.
Mm-hmm.
Kasi at least doon naka-indicate na all positive integers. So we know that in that set N, ba? Tama
Well-defined.
po ba?
Yes, it's actually correct, ma'am. But if we go back to set A, is this well-defined or not well-defined set?
Not well-defined kasi
Not, sir.
uh,
Not.
tama
Bakit
po.
kaya? May I know your justification? Ano yung justification natin? Or what's the reason why
Sir,
we say it's not well-defined?
Sir, possible siguro yung term kasi na word na sum. Kasi it's either naman, sir, yung close to 10, pwedeng larger than 10 or lower than 10, which is na hindi naman nakaspecify kung ano yung number.
Mm-hmm. Yes. So actually, the problem here is the word close, because the definition of the word close might be relative to different people. So when you are provided a number, then you will subjectively decide if it's actually close to 10. For some people, and or in different contexts, 20 is close to 10 because we are comparing it to 1 million. But in other contexts, 9 is close to 10. 8 is not close to 10. It's far. So in that case, we do not actually definitely know if a number is included or an element of that particular set. I'm not sure if you encountered the term fuzzy set. Actually, it's a fuzzy. This is an example of a fuzzy set. If you're going to provide parang may probability something, this is an example of a fuzzy set. Indefinitely fuzzy set, a fuzzy set is not a well-defined set. So ang tinitignan natin dito, whether you are able to tell objects or elements to be included or definitely not included in the set. That makes a well-defined set. Si set N, kahit magbigay kayo ng kahit anong number, mapa-negative man yan, mapa-positive man yan, mapa-fraction yan, irrational, we can always identify for sure 100% if it's an element of N. So if I'm going to say pi, the number pi, well, it's not an element of set N because in the first place, it's not an integer. If we have -3, definitely, it's not an element also of set N because it's a negative number. It's not positive. and any number that we can think of. So, si n ang tama. Well-defined set. Okay, anyway, uh, go, let's dig deeper with proof. So, a mathematical definition, as you can read it here, is always an if and only if statement. If and only if, ang notation natin dyan ay IFF. So, parang if na nasobrahan ng F, that's read as if and only if. So, for example, we go back again to this statement. The sum of two even numbers is even. This is a, if we're going to prove this one, then we need to start by translating it to an if and only if statement. Majority of the statements that you'll be asked to prove is not really written explicitly as an if and only if statement. That's why your first step is to make sure that you understand kung ano yung if and only if. Ano yung if na part and then na part. If and only if, it's the same as A implies Q. So, how do we create an if and only if statement from the statements the sum of the even numbers is even? Then we need to start with assigning arbitrary numbers. Since there are two numbers involved here, the sum of two even numbers, the sum of two numbers, then we need to assign arbitrary numbers, specifically two arbitrary numbers. Of course, we can use any other letter aside from x and y. I just use it here anyway. So let the two numbers x and y, and if we do that, the if and only if statement that is a translation of this statement would be, if x and y are even integers, then x plus y is even. This is actually the statement that we are proving. This is just the same with this statement. Mas madaling mag-prove kasi kapag nasulat natin siya sa ganitong paraan. By the way, we have another term here. This is called the hypothesis and then the conclusion. If then, naging if then na lang siya. That's what we mean by if and only if statement. Meron tayong note dito. Note that the default quantifier in mathematics is for all, which is the same as for every or for any. That is, if a quantifier is not indicated in a statement, it is assumed to be for all. This is what I mentioned kanina, na although wala tayong nakikitang for all dyan, that's really the default meaning. So for all two even numbers, parang yun, no? For all two even numbers, if you add it, it is always even. That is a statement that we are trying to prove. If even one example can be found for which a statement is not true, then the statement is not a theorem. What again are theorem? Ano nga ba ang theorem? Any idea? What is a theorem? Let us not confuse it with the word theory. Anyone? What do you think is a theorem? If you had plain geometry before, or I think set din, meron yatang definition, no? Na-distinguish ang theorem from an axiom, from a lemma. A theorem is a statement that is only accepted as true provided a proof. So yung output natin for proving something is a theorem. If we are able to show a proof for a statement, so naging true siya na prove natin, That is an example of a theorem. Ganon. A theorem that comes directly after a theorem, I think that is called a corollary. Meron ding term, as I mentioned kanina, na lemma. Yes. So, as we mentioned, that is a theorem. Pero ano yung point sa first statement? If even one example can be found for which a statement is not true, so it's a case na hindi naging totoo yung statement, that is enough to say that that statement is not a theorem. That example, that case is called a counter example. So in proving mathematical statements, it is of course always a lot easier to prove something that is false than to prove something that is true. And why is that? To prove something that is false, so meaning it's not a theory anymore, is to ang kailangan lang natin identify at least one counterexample. Yun lang yung gagawin natin. And normally, counterexamples are just specific cases. Ipapakita lang natin kung ano yung nangyari sa case na ito na magiging reason kung bakit natin sasabihin na that the statement is false. If the statement is true and you are to prove it, medyo mas mahirap yon. Why? Because you need to show that that statement is true for all elements there is. So, depende kung ano yung set na pinag-uusapan, if it's the set of real numbers or it's just the set of positive integers. By the way, it also says here that if we're going to provide counterexample, so mamimili tayo ng case. So siguro, the statement is false at x equal to 0. So you're trying to use 0 as a counterexample. You have to make sure that 0 satisfies the hypothesis. So a counterexample is a case that satisfies the hypothesis but does not satisfy the conclusion. We have a lot of examples later on. Yeah. Speaking of examples, ito. So the statement is, if n is even, then n minus 2 is composite. Normally, the letter n is used as a notation for any positive integer type. Anyway, it's even naman, so it's of course definitely an integer. If n is even, then n minus 2 is a composite number. So we're going to prove whether this is true or not. If it's true, it's a theorem. If it's not, then we only have to show one counterexample. That is enough to falsify or to say that this statement is not true. So ano ang possible na counterexample dito? 4. Well, 4 is an even number, meaning it satisfies the hypothesis, yung sinasabi ng statement na ito. 4 is an even number. But when we look at n minus 2, n equal to 4, is it still a composite number? 4 minus 2 is 2. 2 is not a composite number. 2 is definitely prime. So this statement is already a false one. Hindi na siya magiging theorem. So yun yung sinasabi din natin kanina. It's easier to show that it is false than it is if it is true. Mas challenging yung mag-prove na theorem na yung statement na yon. 5 is not a counterexample. Wala tayong pakialam kung 5 minus 2, that's 3. That is not a composite number, it's prime. Actually, wala tayong pakialam na doon. Bakit? Because in the first place, 5 does not satisfy the hypothesis. So, hindi natin pwedeng gamitin ito na counterexample. So, dapat even if this is the statement that we are trying to prove. Yeah, so with 4 as a counterexample, the statement, if n, nawala yung n. If n is even, then n minus 2 is composite, is a false statement, thus not a theorem. Okay, I think I have two statements here. I'd like you to analyze it and tell me if we are to prove that it's a theorem, or you can provide a counter example. So meaning the statement is not a theorem. This is the first statement. The sum of two composite is composite, meaning the sum of two composite number is also a composite number. Can you think of a counter example for this statement? So ang hypothesis natin ay if two numbers are composite, then that's the conclusion part now becomes then the sum is composite. So if you're going to look for a counter example, we have to start with a pair of two composite numbers. Who can provide us a counter example? Because if we can't, perhaps this is a true statement at ang gagawin natin na naman ay magbigay ng proof. What is a possible counter example?
4 and 6, sir.
4 and 6. 4 and 6 are both composite. The sum is
Composite din, sir.
so it's not a counter example because it satisfies the hypothesis and also satisfies the conclusion. Tama ba? A counter example is something that satisfies the hypothesis but not the conclusion. So if it's a counter example, yung dalawang number dapat composite pero kapag kinuha yung sum, hindi siya dapat composite. Ano yung opposite ng composite? Prime. Actually, nakuha mo yung isa ay 4 and it cannot be 6 because their sum would be 10 in this a composite number. How about 9? 4 and 9.
Yeah, yes, sir. 4 and 9.
4 and 9. Why is that?
Kasi sir, 4 and 9 are composite, both composite, but their sum is a prime number, sir. Kasi 13 is a prime number.
Okay. So, nakapag-provide na tayo ng isang counter example, that's enough to say that this statement is not a theorem. So, this statement is true to some but not all. Second statement. N squared minus 1 is even for some integers n. Is this true? Or we'll be able to provide a counterexample? N squared minus 1 is even for some integers n. Let us highlight the word sum. So na-specify no sum, it's not really trying to say that for all. Yes, Mr. Aquino.
Sir, pwedeng example yung 4.
4. 4 squared is 16 minus 1 is not even. But the first question is, Are we going to provide a counterexample for this statement, or we're going to show that it is a true statement? Because remember, it's only saying, it's not actually saying that n squared minus 1 is even for all integers. Ang sabi lang naman niya, for some integers. If n is 4, it's correct. It's 16 minus 1, which is 15. Add siya. Pero is that really the point here in this statement? This statement, n squared minus 1 is even for some integers n. This is true if we could find some integer that satisfies the criteria, tama ba? So n squared minus 1, this statement is actually true. We can prove it. Bakit? Because we can identify some that will satisfy the criteria. So halimbawa, 5. 5 squared is 25 minus 1, 24 is even. So merong example, merong case na integer na kapag in-square natin and then subtract 1 from it, the result is an even number. So the idea here is the use of the word sum. In this statement, although wala siyang sinabi na for all, pero sabi natin kanina na kapag walang sinabi, that's understood to be for all. So this is a true statement if this true, if the criteria is met for all two numbers, for all two composite numbers. But dito, nakaspecify naman na sum. So ang hinihingi lang niya ay kung makapagbigay tayo ng some integers that will satisfy this one. Sa number 1, for all. So number 2 is true. It's a true statement because again, we are able to provide an example of it, a specific example for it. Okay. So to sum it up, these are reminders when we are doing proving. A theorem for all quantifiers is proven by showing that the statement is true for each element of the set under condition. This is done by using an arbitrary element. On the other hand, a theorem for some quantifier is proven by giving at least one specific example. Yung counter-example, pang-counter yan sa for all na statements. A theorem of the form if hypothesis then conclusion cannot be proven by giving a specific example where the hypothesis and conclusion are all true. So, tandaan natin lagi ito na ang example kahit gaano pa karami yan, if we are trying to prove a statement na for all, kahit gaano pa karami yan na specific examples, it will not actually be considered a proof, a mathematical proof. A theorem for all quantifiers cannot be proven by giving, yes, specific examples regardless of the numbers of examples. Only theorems with for some quantifiers can be proven by giving specific examples. Deducing a correct statement from the conclusion does not constitute a proof, as I mentioned kanina. Suppose we wish to show that an element having some property exists and is unique. First, show that there is, this is just a note, no, a side note lang ito. We are showing that something, a property exists. So, proof of existence. Ang gagawin natin, we're going to assume that there are two such elements, R and S, and show that R and S must be equal. I have an example for this in the proceeding. I mean, in the next slides. So that is all about, or the general idea about mathematical proofs. Now we are going to discuss some of the mostly used or applied methods of proof. So we can see now already here that the first one is called the direct proof. Direct, I'm not sure. Direct proof. what is this method of proof? The conclusion established by logically combining the actions, definitions, and earlier theorems. So, this is normally applicable kapag meron tayong alam na information about the statement that we are proving, especially the hypothesis of the statement. It usually starts with the assumption of the hypothesis and then arrives at the conclusion. Okay, let's provide an example. Walang kamatayang the sum of two even numbers is even. So again, of course, we assign arbitrary numbers, no? Two even numbers. Let that be n and m. Kanina yata x and y, it's okay. We need to show that the sum is even and n plus m is the expression, no? It's the sum. So this is the start of the proof. If n is even, then we can express n something as to or into something like this. It's 2k. For some k, kindly take note of our notation. Yung inverted e, that is read as for some k, element of. What is this? This is zeta. This is a notation representing the set of positive integer or of integers pala, general. Of all integers, and since m is also an even number, then we can actually express it similarly. This time, we're going to make use of another variable p. Not to confuse with k, no? Well, p and k here can be equal. They can also be not. For some p, element of the set of integers. And why are we doing this? Because we know now the definition of even numbers. So the definition is really important. From there, we're going to, because we are talking about the sum, so we're going to now add the values. N plus m is equal to 2k plus 2p. For some k and p, element of the set of integers. And rewriting 2k plus 2p, we have 2 times the quantity k plus p for some kp element of the set of integers. Now, what do we learn from here? N plus m is equal to 2 times the quantity k plus p. The quantity 2 times k plus p means that n plus m is even. Why is that? Because twice the sum of two integers is always divisible by 2. So if it's divisible by 2, nakamultiply yung 2 dito kasi eh. So we can always divide it by 2. So it's divisible. This expression here is divisible by 2. So regardless of not knowing the values of k and p, kung i-add mo lang yan, basta number lang naman yan, integer yan. Kasi k and p are just some integers. Pero pwede natin siyang i-divide ng 2. That's definite. So we are sure that this expression is divisible by 2. If it's divisible by 2, then it is even. That is the end of the proof. So we are now able to show na for all n and m, if they are even, then their sum is also even. So ganito yung itsura ng proof natin later on. This is a proof showing that this statement is now a theorem. Because of this proof, we can now say that this statement is a theorem. By the way, in this course, let's just agree, we're going to make use of this as a sign for a proof that is elegantly done. If you recall QED, do you know what QED is? Alam ba natin ang QED? Ano na yung QED natin? Hello, are you still with me? QED, quaderat. I'm going to pronounce as the spelling as it sounds. Quaderat demonstradum. I think it's Latin. Ginagamit natin yon sa dulo ng isang proof. So kung natapos natin, nakapagbigay tayo ng proof, naglalagay tayo ng symbol like demonstrated elegantly. Yun yung ibig sabihin yata ng erat demonstradum or in short, QED. An alternative for that is this square. This, minsan nga sulat lang, hindi siya shaded. Pero let's use the shaded one. This is more traditional. This is an alternative for QED. So kung dahil natapos natin yung proof na ito successfully and we know that this is a theorem, naglalagay tayo dyan ng symbol na yan. This is a tombstone symbol. Meaning, na-demonstrate natin na this is indeed a theorem. Yan. So yun yung ibig sabihin ng square na ito. So you will be seeing this one most of the time pag na-prove natin ang isang theorem. Okay. Let's now proceed to another method of proof. So yung direct proof, we assume the hypothesis and then by manipulation, by doing something about that, the assumed hypothesis, we're now going to conclude or to arrive at the conclusion part, direct proof. And what do we use? Again, we use axioms, definitions, existing theorems. So why can we use existing theorems? Because they are theorems, no, they are true for all cases. In fact, if there is a problem later on in the future that would involve this one, actually we can use it already because we are able to prove it. So if the two numbers are even, we automatically know that their sum must be even. Second type of method of proof, it's proof by transposition. What is this? Proof by transposition, otherwise termed as proof by contrapositive, establishes the conclusion if P, then Q, by proving the equivalent contrapositive statement. If not Q, then not P. So, sa set and logic theory ninyo, mapapag-aralan nyo ito. The so if P then Q, that is an example of a conditional statement from your set and logic course. That is a conditional statement, if and only if pa rin siya na statement. Now, meron tayong tinatawag na contrapositive. What is the contrapositive of a conditional statement? It's still a conditional statement, pero galing siya, it starts from the conclusion of that conditional, of the original conditional statement. So we negate the conclusion, kaya if not Q, then ang magiging conclusion dito ay yung hypothesis ng original na conclusion. So, if not Q, then not P. So, na-negate din pala, no? Sorry, na-negate din yung yung ating hypothesis dito. So basically, this method of proof starts with the negation of the conclusion part of the theorem, then arrives at the negation of the hypothesis part. There, I think that is clearer. This is the format of our proof when we use this method by contrapositive or transposition. So we have the statement. This is the statement that we are trying to prove. If P, then Q. And if we're going to make use of this method, we're going to start with an assumption. We suppose that Q is not a true statement. So negate natin. So kung Q siya, not Q is the symbol for its negation. Dapat, after our proof, we will arrive at the negation of P. This is the hypothesis of the statement we are trying to prove. Ayun. Si tombstone ulit. Kapag na-prove natin yan. I think I have an example here. The statement that we are going to prove is if 7x plus 9 is even, then x is odd. What is the symbol? Yung parang inverted na capital letter A. How do we read this again? Ano na nga ito? How do we read it? There exists ba? Yung there exists or for some, yun yung inverted na E. Ulitin natin, yung there exists, parang yung inverted na E. Yung existential notation. Pero yung ito, yung inverted A, yan ay for all. For all. Basahin natin ulit yung statement. If 7x plus 9 is even, then x is odd for all x element of the set of integers. Now, we're going to prove this statement and say it is a theorem by transposition. Proof by transposition. Now, meron akong nilagay dito. If we are to use direct proof, pwede naman. This is how we do it by direct proof. First, we assume 7x plus 9 is even. So, yun kasi yung hypothesis. So, that is where we start. For some k element of the set of integers. And then, from there, because we want the value of x, we are interested of knowing the expression, an expression for a general expression for x. So from this level, from this stage, ang ginawa natin dito by APE, addition property of equality, nag-add tayo ng negative 6x plus 9, quantity 6x plus 9. Why did we do that? Because we want na ang matira sa left side ng ating equation ay x. So, syempre, para maging x ang 7, mag-minus tayo ng 6x. And gusto din natin mawala ang 9 sa left, kaya mag-a-add tayo ng, or magsusubtract tayo ng 9. If anything that we do here, we have to do it in the other side of the equation. That's the addition property of equality. The equality remains as long as we're going to add the same amount to both sides of the equation. Actually, hindi ko na nilagay yung APE dito kasi medyo basic na yon. So, from there, x would be equal to 2k minus 6x minus 9. Saan galing ito? This is just the simplification. Tinanggal lang natin yung parenthesis dito. So, 2k minus 6x minus 9. For some, sa logic, there exists, ganun, pero in this context kasi, hindi naman there exists k or some k element of integers. And then what's the next step? Anong ginawa natin dyan? Negative 9 can be expressed as negative 10 plus 1. So negative 10 plus 1 is the same as negative 9. Nire-write lang natin ang negative 9. So that's still okay. That's mathematically valid. Now, for the first three terms sa right side, 2k minus 6x minus 10, they are all divisible by 2, so I can factor out 2. So it now becomes 2 times the quantity k minus 3x minus 5. Siyempre, hindi kasama yung 1 kasi hindi naman siya divisible by 2. Now, what is this expression? What does it say? X is always 1 more than twice an integer. K minus 3x minus 5, regardless of the values of k and x, kahit hindi natin alam yan, or kahit anong numbers ang k and x, if you have k minus 3x minus 5, meaning from k you subtract thrice x, and then you subtract again 5, the result will always be an integer that we do not care about, times 2. So, if a number is always 1 more than twice a number, we are sure that x is always an odd number, which is our conclusion that we are trying to show. since na-conclude natin na it is always odd because of this form, because it's of this form, then we can say that this is a theorem. Remember, hindi ako naglagay ng specific examples. Hindi ako kumuha ng even numbers na 10, tapos sa 10 even numbers na yon, isubstitute ko sa 7x plus 9, tapos even lahat yung result in that now constitute a proof. Hindi. Kasi hindi naman for all x yon, for some lang. For some x, selected values of x. Now, this is a direct proof, which is the previous method. We are trying to prove now by transposition. I included this one so that we could see the difference. By transposition, this is how we're going to do it. So ano na ulit yung gagawin natin? First, we assume the negation of the conclusion. Ano ba ang conclusion sa statement natin? X is odd for all x. If you negate that, ano ang negation ng odd? Is odd, is not odd. Suppose x is not odd. Bakit ito yung statement natin? Because this is a negation of the conclusion of the statement we are trying to prove. This is the first step for using this method. What is NTS? This is short for need to show. Need to show. Ano yung need to show natin? The negation din ng hypothesis natin. So the hypothesis is 7x plus 9. It's even. If you negate it, it should be 7x plus 9 is not even. So yun yung sinasabi natin kanina na not Q implies not P. The contrapositive of this conditional statement. Now let's look at now the proof. How do we start? If x is not odd, that's the same as x is even. By the way, yung mga ibang proof dito, it's really funny kasi we might think of them as very obvious, but it's really that's the process of proving that I want you to be familiar with. Okay, if it's even, we know how we express an even number. It's, again, of the form twice an integer for some key element of the set of integers. Now, from here, I can always add a quantity to x, provided that I'm going to do the same to the other side. That's the addition property of equality. Now, what is that quantity that I'm going to add? I can add anything, but of course, I will add something that will complete the proof. So, because we are trying to look at the value of 7x plus 9, ang gagawin ko, I'm going to try my best to make x parang translate or become this expression 7x plus 9, but by using valid mathematical ideas or mathematical tools. And that is, ang ginamit ko dito is APE. So mag-add ako ng 6x because 6x plus x will provide me 7x. And then also, I'm going to add 9. So that in the left-hand side of the equation, we have now the expression 7x plus 9. To make it fair, APE nga, kailangan i-add natin yung the same quantity dito. So we have now 7x plus 9. This entire expression is just or can be rewritten as 2k plus 6x plus 9 for some k element of the set of integers. What's next? 9 is the same as 8 plus 1. So meron talagang involved din na creativity sa proof. We have to be creative. Bakit ko ginawa yon? Because I can see that this is the only odd number doon sa tatlong terms. So if I'm going to segregate or separate 1 from 9, then that will become an even number. So I can actually factor 2 from the first 3 terms here. Magiging 2 times k plus 3x plus 4. Siyempre, plus 1 yan. So what does this mean? The expression 7x plus 9 is always odd or even. 7x plus 9 is always odd or even based from this last line. Anyone? Anong ibig sabihin nito? 7x plus 9 is always even or always odd based from this form. Just answer na lang sa ating chat box, even or odd.
Odd, sir.
Okay, yes. It's odd. Kasi naka plus 1, no? So, twice an integer plus 1. Kapag walang 1 dyan, then it is always even. 7x plus 9. Kahit hindi natin alam ang value ng x, it's even kapag wala si plus 1. Pero kung mayroon, that makes it a number that is always odd. So what do we deduce here? 7x plus 9 is always odd because it is 1 more than twice something. Twice an integer actually. So 7x is not even. Because 7x plus 9 is odd, that makes it 7x plus 9 is not even. So we were able to come or to arrive at the negation nga na yun yung need to show natin kasi kailangan nating ipakita. So the proof stops here. Why is that again? Because we are able to show the contrapositive. We started from the negation of the conclusion and arrives at the negation of the hypothesis. Okay. This is a third method of proof, and this is perhaps the most prevalent mathematical proof by contradiction. This is sometimes referred as reductio ad absurdum. Absurdum. That's Latin for reduction towards the absurd. It is shown that if some statement were so, a logical contradiction occurs. Hence, the statement must not be so. But I think the third statement here is more useful. This method of proof uses the idea of proving the negation of the theorem to be false. That is, if the negation of a statement or a proposition is false, then the statement or proposition must be true, considering that a proposition is either true or false, but it cannot be both true or both false. So how do we do it? We assume the hypothesis part and the negation of the conclusion part of the theorem. Our goal is to come up with a contradiction. A contradiction could be any statement that is obviously false. For instance, A, I was not able to encode it here, pero X is positive and X is negative. So X is both positive and negative. That is a contradiction. That is an example of a contradiction because again, a number can be either positive lang or negative lang or zero, but cannot be both positive or negative. That is a contradiction. So we go back again. How do we do it? Assume the hypothesis and then negate the conclusion. After working from there, dapat maka-arrive ka ng negation, ng contradiction, I should say. A contradiction could be anything like our example here. A negation is something like also like 2 is equal to 1 because obviously 2 is not equal to 1. Mga ganong contradiction yung hinahanap natin. Or sa statement natin sa taas, sa assumption, A is greater than 0. But after manipulation, nagkaroon tayo ng contradiction sa baba na A is equal to negative 2. Well, that is a contradiction because A should be or must be greater than 0. Ganong contradictions. Let's provide some examples. Prove that if n squared, the square of n is an even integer, then n is also an even integer. n squared is an even integer, then n is also an even integer. Proof by contradiction. Now, how do we do it again? We are going to assume the hypothesis. So the hypothesis is n squared is an even integer. Kaya let n squared be an even integer. And suppose, ito na yung negation ng conclusion. N is also even doon sa original statement. This is the statement that we are trying to prove. But by proof of contradiction, kailangan nating i-negate ngayon yung conclusion. And then by working from here, we should arrive at a contradiction. We don't know yet the contradiction. We'll be able to know that when we do it. So let's start working the proof. If n squared is bakit iba? N squared is I think it's the statement na mali. Ito na hindi tama pala. Galing pala dito. Suppose n is odd kasi. Let n squared, so tama. And then we negate the conclusion. So from here, hindi pala dito. We start from here, n is equal to 2k plus 1 because we suppose that n is odd. This is the definition of an odd number. Can we square both sides? Is this a valid step? Yes, as long as you do it to both sides of the equation. Diba? Parang multiplication lang yan. Or multiplication ba? You're raising two quantities that are equal. If you raise their square, must be also equal for some k element of the set of integers. Now, 2k plus 1, the square of 2k plus 1 is this trinomial. So 4k squared plus 4k plus 1. And we can factor out 2 to the first two terms. That's why we have 2 times 2k squared plus 2k plus 1. So obviously, again, n squared is odd. This shows that n squared is 1 more than twice an integer. That is, n squared is odd. It's an odd number. Now, where is the contradiction? If we're going to combine it with the assumption natin dito sa taas, we have n squared is even. Pero in our conclusion dito, the last step, it shows that n squared is odd. But n squared cannot be both even and odd. Kailangan isa lang doon. This is a contradiction. So because negating the conclusion would give us a contradiction, we have no other ways than to accept now the original statement. Kasi may contradiction nga if we do not accept the statement. That is proof by contradiction. Yes. All right. Proof by mathematical induction. This is a proof composing of two steps. We have the base case and the induction case, induction rule. I'm not going to discuss this one because this is the last part of the preliminary chapter. So we'll devote a different lecture for mathematical induction. So for now, we're going to skip this one. We have the two-column proof. This is very applicable, no? Saan? Any one of us teaching geometry, Meron na bang nagtuturo sa atin ng geometry? Plane geometry. Meron pa ba sa junior high school? You still there?
Yes, sir. Pero sa grade 8 ata siya, sir, if I'm not mistaken. Grade 8, third or second quarter.
Diba? Meron, tinuturo nyo ba yung proving? Because that is an example of this proof. Prove that angle B is congruent to angle C given that these line segments are congruent, AB and AC. So, bakit siya two-column proof? Kasi we use two columns. The left column is the statement, are the statements, and then the right column is the reason, the explanation. This could be a definition, this could be a theorem, previous theorem, meaning a statement that was previously proven, or properties. CPCTC. Ano yung CPCTC? Congruent parts of congruent triangle are congruent. You know. What are other methods of proof? Proof by construction. Meron talagang kino-construct. Yun yung key term dito actually. But when we say proof by construction, dapat ang ideas lang natin hindi siya limited sa geometry. Although prevalent siya sa geometry, kasi construction talaga, pero hindi kailangang sa geometry lang. I think I have an example here. Let's start. Let's provide an example sa geometry muna. I think naka-video siya kasi mahirap gawin yung construction. Wala akong protractor.
Geometry. Let's prove that for any line segment.
Were you able to hear that?
Yes, sir.
Okay. Let's proceed then.
L1. There exists another line segment, L2, that is a perpendicular bisector of L1. Note that drawing L2 in this particular case doesn't prove our claim. We must prove that there exists such an L2 for any initial L1. We can do that by construction.
Using compass and straight edge, we seek to find a perpendicular bisector of the line segment L1. To do that, first we take the compass and set the distance on the compass to the length of the line segment L1. Then we draw some arcs from the two endpoints to get these 2 points, which then are equidistant from the endpoints of the line segment L1. Connect those 2 points using a straight edge, and the claim is we have created a perpendicular bisector of L1. We shall call it L2. Now, we won't go through the proof of why that is, but just a sketch of the proof. If we put in some triangles right here, what we could show is that this angle is equal to this angle, and that this length is equal to this length. The two angles being equal guarantee the perpendicularity of the line L2 with respect to L1.
Okay, so anyway, just to recall, no, have something for you to recall. But I know that you are familiar with what we mean by proof by construction. I have another video.
Let's prove that for
Ito ba yun? Ito. In a different field naman of mathematics, pero proof by construction, a graph theory.
In mathematics and computer science, we define an important structure called a graph. In this context, a graph is a set of nodes, sometimes also called vertices, and a set of edges, each of which connects a pair of nodes. Notice that it's possible for an edge to connect a node to itself. The degree of a node is the number of edges that touch it. So, for example, this node has degree 3. A regular graph is one in which every node has the same degree. So this graph is regular. Every node has degree 2. But this one isn't, since these nodes have degree 2 and these have degree 3. An n-regular graph is a regular graph in which every node has degree n. So this is a 2-regular graph. Every node is touched by exactly 2 edges. And this is a 3-regular graph. 3 regular graphs are also called cubic graphs. Graphs are important because they can be used to model a huge range of things, from molecular structures to the internet. So claims about them matter. Consider the following claim. For any even n greater than 2, there exists a cubic, 3-regular graph of size n. We want to prove this claim. We can't do that by exhibiting any individual cubic graph, say this one. All this example proves is that the claim is true when n equals 10. We need to prove that it's true for every even n greater than 2. We can do that by construction. We'll present an algorithm whose input is n and whose output is a cubic graph of size n. First, arrange the nodes in a circle. Connect each node to its neighbor on either side. And now connect each node to the one opposite it. We know that it's possible to do this last step because the number of nodes is even. So, at the end of this process, each node is connected to its 2 neighbors in the circle and its opposite. So, each node has degree 3. By the way, construction proofs often aren't unique. Let's look at another simple construction that also proves our claim. Arrange the nodes in 2 concentric circles, with half the nodes in each circle. Connect each node to its neighbor on either side. Now connect each node in the outer circle to its matching node in the inner circle. By the way, physical layout isn't important in graphs. Only connectivity matters. So we didn't actually have to use.
Alright. Kinat ko na yan. Again, this is a topic under the graph theory.
In mathematics and computer science, we define.
I have a third example here. Proof by construction pa rin siya, but it's a bit different. So this is the problem. If a and b are real numbers and a is not equal to 0, then there exists a unique r such that ar plus b, the linear combination ar plus b equals 0. So you see, this is not geometry or anything near that, but still the proof is termed as proof by construction pa rin. Anyway, in this problem, there are actually 2 things that we need to prove, to show. The first one is an existence problem, proof of existence, because we need to show that there exists. At the same time, if it exists, it has to be unique. So there are 2 concepts here. Kaya dalawa yung proof na ipapakita ko. Let me start with the existence. Prove existence by construction. So, we start from here. AR plus B equal to 0. We need to show that R, ano nang ulit? R exists. By algebra, we can actually solve for R equal to negative B over A. And it's provided there that it's not equal to 0. A is not equal to 0. So this is actually a proof of existence. It exists because R is equal to negative B plus A. We are sure that this is a number. Hindi siya undefined. Hindi siya pwedeng undefined kasi naka-restrict na A is not equal to 0. Now, yeah, just as I said. So the proof ends there. But again, this is only the proof for existence. Now we need to prove the uniqueness. by contradiction. So, hindi na siya construction by contradiction. I just want to show you na pwedeng maghalo-halo yung ating methods. So, uniqueness naman by contradiction. Paano na natin ulit ginagawa yung contradiction? Assume the hypothesis and then negate the conclusion. And then after that, you should arrive at a contradiction. So, what is our conclusion here? R is unique. Tama? That is our conclusion. If we're going to negate it, then we would say that, so anong negation? R is not unique. That's a negation. If it's not unique, then there exists another value S different from R that satisfies this equation. So meron ibang number, sabihin nating S, na AS plus B. If we're going to solve that, it's equal to 0. Now, since both of them are equal to 0, then the quantity AR plus B is the same as AS plus B. APE ulit, addition property. So we add negative B to both sides. We have AR plus, AR equal to AS. And that would give us R equal to S. So, tapos na ba? Yes. Why is this a contradiction? Because we said that there is a unique or there is another value S. So R and S are supposed to be not the same. But it shows here that R is equal to S. This is a contradiction. Because they cannot be different at the same time equal. So this statement now becomes a theorem because of this proof. What else do we have here? Meron tayong tinatawag din na proof by exhaustion or proof by cases. What do we do here? The conclusion is established by dividing it into a finite number of cases and proving each one separately. Nasa pangalan, proof by cases. Halimbawa, nagbigay tayo ng example. This is a statement that we're going to prove. We are going to show that n is an integer. If n is an integer, then n is less than or equal to n squared. For all yan, for all n element of the set of positive or integers pala. Hindi lang siya positive. Now, the first step, kasi nga proof by cases, is actually to divide yung set natin, yung for all natin, for all n element of the set of integers, we need to divide that. Yun yung magsisilbing cases. So how do we divide? Maaaring yung case 1, we show muna for n na less than or equal to negative 1. And in case 2, specific to 0. And in case 3, greater than or equal to 1. Now, if you look at it, if we take the union of this set, this will comprise the original set of integers. We are just dividing it into cases. Now, why do we choose to use this method? If we look at the statement, kasi it involves squaring. And normally, squaring a number changes or is different. The result becomes different sa negative numbers, sa 0 at saka sa positive. That's why we are using this method to establish this one, to show that this is a theorem. So, ganon, case by case talaga natin na ipapakita. Let's start with the first case. If n is less than or equal to negative 1. Now, how do we show it? If we square something that is negative, kasi mag-start tayo sa negative 1 eh. So, negative 1, negative 2, negative 3, and the numbers less than it. If we square, we are sure that those are greater than 0. So it follows that n is less than or equal to n squared. So na-prove natin yung statement for the first case. For case 2, because it's specific, n is equal to 0, then we simply substitute and determine whether the statement is correct. So n is less than or equal to n squared. But if n is equal to 0, then we have 0 is less than or equal to 0 squared. Is that true? Yes. Because specifically 0 is equal to 0. So na-prove natin ulit yung statement in the second case. Lastly, we show case 3. That is if n is greater than or equal to 1. So anong kasama dito? 1, 2, 3, 4 to the positive infinity. Pero integers lang ang pinag-uusapan natin ulit dito. Hindi siya real number. Now from here, we can actually start working from this inequality by multiplying n to both sides. So we have n squared is greater than or equal to n. This inequality is just the same as this one, di ba? N squared greater than or equal to n, that's just the same as n is this less than or equal to n squared. We are now done with the proof. Okay. Elementary proof. This is, I think, just a general classification. An elementary proof is a proof which only uses basic techniques. More specifically, the term is used in number theory to refer to proofs that make no use of complex analysis. And we have computer-assisted proofs. Although there are a lot of issues now with proofs that are a product or an output of a computer algorithm, at least familiar lang tayo. If you know your four-color theorem, meron yatang nag-prove doon using computer algorithms. So nasa pangalan, computer-assisted proofs are those proofs na ginawa sa pamamagitan ng computers. Actually sa ngayon, one of the most challenging problem sa pure mathematics ay yung pag-express ng prime number. Parang ang even number, that's very easy, 2k. Ang odd naman, 2k plus 1. But is there a way to represent all the prime numbers? So actually, hanggang ngayon wala pa. But they are using computer to look at the nature or the behavior of prime numbers as we move to the positive numbers. Actually, there is an observation na as we move to the positive infinity, mas kumukonti yung mga prime numbers. Mga tipong ganon. I think this is the last method of proof. And this ends this slide, I mean. Meron pa pala. Our lecture today. Just so to summarize everything that we discussed, the first four methods of proof are commonly used in this course. So ano yung mga yon? Direct, contradiction, transposition, at saka mathematical induction. Although we haven't discussed yet mathematical induction. Normally, yun yung mga proof na gagamitin natin sa klaseng ito. Before we attempt to prove a theorem, we have to make sure that we clearly understand the statement of the theorem. Coming up with examples and counterexamples may help us understand the theorem. Proving is like a problem solving, so following the steps of problem solving may help. What? Meron ba sa inyo ang nagtuturo ng mathematics in the modern world sa tertiary level? Pinag-uusapan doon yung problem solving, yung process, polya, mga ganun. In our next topics, onsets, yes, our next topic is in onsets, relations, and functions. We will be writing formal mathematical proofs. The given examples were just illustrations on the concept under discussion, particularly to illustrate how to write a formal mathematical proof. Yes, that's it. Okay, so I'm going to give you now your first activity. So very traditional yung ating course. I have the question, you have the question here. You just have to solve it in paper and pen. So kindly handwrite your answers. I'm going to make an activity sa ating Google Classroom para lang dun yung ma-submit. There are only 5 questions here, and the instruction is to identify whether the statement is true or false. So if you think it's false, then you should be able to provide at least one counter example. If it's true, then you should be able to provide an entire or complete proof. All right. So we have 5. Do you have questions before we end our session? Mukhang diretso yung lecture natin, no? For this entire week, we will devote it to the preliminary topics. Actually, marami pang preliminary topic na i-discuss sa course na ito, para sa course na ito. Kindly take a screenshot siguro of your screen or picture para hindi makalimutan itong activity. Or I can just flash it now. You can actually copy it. 5 lang naman. Integer dapat yun, number 3. N squared is greater than n for every integer. Tama pala. Integer n. May space. May space doon.